I'm Oluwatoyin AYetigbo, and I would be presenting to you a standard operating protocol for determination of extensibility of pounded yam. Contributors to this work include Romain Domingo, who is in charge of the physical lab here in CIRAD. Santiago and I also worked along with him to produce this SOP, and Dr. Christian Mest is working on the validation of this SOP. So thank you very much once again, and I would like to start right now. A brief outline of what the SOP development entails. First, I'll show you the materials that are required for conducting this SOP, the tests for measurement of extensibility, preparation of pounded yam sheet and the measurement of it, and the critical points that should be considered for the SOP, preliminary work that was done, and then the validation exercise that was conducted for the SOP. I would also be giving you information on correlations we've seen so far with sensory data, as well as future application of this method. In brief, the SOP includes the determination of extensibility of dough that is made into the form of a sheet. As you can see, it's a thin layer of product. So the product is made into a thin sheet, which is then impacted on by the probe. So you have the texture analyzer itself, which is a stable microsystem equipment, a P1SP standard ball probe, and the bus rig, or the platform by which we can conduct these tests. So this is how the setup looks generally. We shall see more of these pictures later. So the idea is that we are trying to see how extensible the dough is when a uniaxial force is applied on the surface of the dough. So it penetrates the dough until it reaches a particular until it stretches up to the point where product failure occurs. After that, we disregard the other parts of the profile. The other materials that we need in conducting this SOP include the pounded yam mixer, which was imported from Nigeria. We have an incubator, and we also have a pasta roller, which can be commonly purchased in supermarkets. Other materials include the chronometer to monitor time, bowls, plastic cups, stainless steel knives, cutting board, mass balance, and a digital vernier caliper to determine the approximate thickness of the dough sheet. For conducting these tests, it is necessary for us to conduct it under standard operating conditions. And some of these conditions include the fact that this test is made with a compression mode using a probe, P1SP standard probe, which can be supplied by the manufacturer. A load module of 5 kilograms is used because it's a thin dough, and the load module can sustain the amount of force that is required to break the dough. A pre-test speed of 5 millimeter, test speed of 1 millimeter per second, post-test speed of 10 millimeter per second, trigger force of 5 grams, and we are measuring basically the distance it takes for the probe to deform the material permanently. And this occurs over a distance of 40 meters from the base of the bus rig. To conduct the SOP, what we have to do first is the yam tubers are cleaned, cut into 2 longitudinal halves, and the proximal and distal sections are removed from both ends. So from the central sections, we can cut out 2 centimeter cube, approximately 2 centimeter cube cubes from the central section, but it must be represented from both tubers. For instance, we have tuber 1. You can see tuber 1 and tuber 1, tuber 2 and tuber 2. So we have to take half of tuber 2 and half of tuber 1, and from this we obtain these cubes. So we need 450 grams of the yam cubes, and we will fill 250 mils of distilled water, or it could also be tap water, into the receptacle of the pounded yam mixer. Having done that, we fit other appurtenances, and then we put in the 450 grams of the yam cubes. And then these yam cubes are allowed to boil to steam for a period of 21 to 24 minutes, depending on the time the alarm system in the yam pounder notifies us. So having completed the steaming part of cooking the yams, it's then pounded with the same machine for about 1.5 minutes to produce the yam dough. On obtaining the yam dough, we roll the yam dough between the palms of the hand into balls, spherical balls of about 43 to 50 grams. And we place this in plastic cups with covers. So these plastic cups are what we place in the incubator, which is already set at 55 degrees C. And this is placed there for about 12 to 20 minutes to allow for stress relaxation and temperature equilibration as much as possible. Also, we have to consider this short time to reduce the amount of moisture loss that may occur, which may critically affect the hardness of the dough. So having allowed the dough to relax and partially at least equilibrate in temperature, we bring out the dough and we roll it into a sheet of about 1.5 millimeter thickness using a pista roller, as you can see here. So this is an illustration of how the dough sheet looks like after rolling it into a sheet. And you will see that we are measuring the temperature in the center of the dough using infrared thermometer to determine when to start the test. It's important for us to ensure that the dough sheet reaches the temperature of at least 30 degrees C before the test is initiated. If temperature is not regulated, there might be considerable textural changes during measurements. On the right, we can see an exemplary chart of how the force against time profile looks on the Exponential Connect software. You will see that the force of the material continues to increase until it reaches the point where the product fails. The formation is complete and then the product fails. And from that point, you have a reduction in the force with time. And that is at the reversal phase of the probe. So the probe is going down until it reaches, the force is triggered when it comes in contact with the dough sheet, and then it starts penetrating the dough sheet, compressing it until it breaks off the product integrity fails. So at that point is where the maximum force is measured, and that maximum force we consider it to be the hardness of the dough sheet. So from the initiation of the test, T0, until Tmax, which is the time at which you have the maximum force, these are important, as well as the area under the curve, A, represented by A, shows us the amount of the total work that is done to result in the maximum extension of the dough sheet until the product fails. So some critical points that we should note if conducting this standard operating protocol is to ensure that your texture analyzer is already switched on and calibrated for force and distance prior to measurements for at least 15 minutes. Also ensure that the pesta roller, which you use to roll the dough into a sheet, is cleaned, and the probe is also cleaned periodically to remove residues. You must also ensure that the dough sheet is not sagging at the initiation or at the start of the test, because if the dough sheet is sagging, then it's possible that you might have a higher magnitude of distance or extension of the dough, and this may not be accurate for measuring extensibility of the dough. You also must ensure that the temperature is monitored and is conducted at 30 degrees centigrade. From the preliminary assays that we conducted for this test, we used two varieties of yams from France here. One is a rotundata genotype, and the other is a species, and then the other is an alata species. And what we did was that we have 100%, we call it Ghana yam. The rotundata yam is called Ghana yam, and the alata yam is a yam that was imported from Costa Rica. So what we did first is we want to know at what time is best to proof the dough in the incubator. So you will see the time against a normalized measurement, where you see that between 10 minutes to 20 minutes, or let's say 30 minutes, is where you have more stable readings or more stable normalized values for the time it takes to reach the maximum force for each of the dough sheets that was tested. So below 10 minutes, you have a scattered plot, which is not within the limit that we would want, as well as beyond 30 minutes, you also have scattered plots points, which may not be what we need. So what we need is just between 10 and 30. However, conducting it at 30 minutes after proofing of the dough sheet, the dough is not advised, because the longer it takes for the dough to remain in the incubator, then the more moisture you lose, and then the more the texture of the dough is altered. So the dough is relaxed for at least 12 to 20 minutes, because it's a range of time, because it's not possible for you to measure, to take your measurements for the different dough samples that will be measured at the same time. So it takes a range of time for you to do that, and it's between 12 to 20 minutes prior to rolling them into the sheet. So this time is due to the sequence of placement and the retrieval of the sample from the incubator, since it's not practical to measure the samples at once. So now that we have confirmed that we need to take the reading, roll the dough into a sheet at about between 10 and 20 minutes, we can then conduct some tests to see if this operating protocol is accurate and if it's reproducible. So to do that, like I said, we obtained two yam varieties from France here, because we do not have the varieties from other locations. So we use these to conduct a preliminary test. And what we did was that we made a use of 100% Ghana yam to produce the Yamdu, pounded yam. We used 50% Ghana yam, 50% Brazil yam to produce pounded yam. And we also used 75% Ghana yam and 25% Brazil yam to produce the pounded yam. And we compared these three properties that were measured during these three attributes that were measured during the test. So if you look statistically, we found that there was good repeatability for the experiments that was conducted because there was no significant difference between the replicates that were conducted for this test. We conducted 2 different replicates per test run. So there was no significant difference, and this gives us an indication that the protocol is somewhat reproducible. Considering the difference in the means of the attributes, we considered, for instance, extensibility alone as one of the attributes. Looking at the extensibility, we see that there is quite high significant difference between the 3 compositions that we used to make the pounded yam. There was significant difference between the 3 yams, compositions of yams. And we see that this difference quite shows us that there is a high likelihood that there may be significant difference or discrimination between yam varieties in the actual experiments that will be conducted in the future. So we can see from the connecting letters that there are significant differences between these compositions. Now, in the actual experiment that was conducted to validate the SOP, we collected 4 yam genotypes from Benin, Aga, Wete, Inido, and Laboko. They were imported from Benin to France, and in our lab, we conducted this extensibility test. Again, we can see from the PCA, principal component analysis of the first 2 components, which confirms that we can describe at least 99% of the variability that occurs within the genotypes. So from this, you will see that there are 3 genotypes that appear on the PCA. The 4th genotype, which is Aga, does not appear because it was impossible to form a dough sheet from the genotype. So if we make it into the pounded yam, it was really difficult for Aga to produce a nice dough sheet. So you see in the PCA that the 3 genotypes shown here are clustered separately and uniquely from each other. And more importantly, you will see the discriminants between the 3 genotypes. They are clearly separate from one another, clearly discriminating from one another in terms of all these 3 attributes that were measured: extensibility, area between the T0 and F max, and the hardness of the dough sheet. So what we see is that amongst these 3 attributes, the area between T0 and F max was seen as the most discriminant attributes. So this represents the amount of work that was done to extend the dough until it is structurally deformed permanently. So with this gives us an idea that this SOP can really discriminate between contrasting genotypes of yams when made into pounded yam. From the PCA, we also, in Benin, the sensory analysis for these 4 yam varieties were conducted, as well as consumer acceptance test. And what we see is that Laboko seems to fall within the component space where all of these attributes correlate really, really close to one another. They all correlate very close to one another, both the sensory and the instrumental attributes that were measured. For instance, moldability and stretchability were measured by sensory analysis using 8 to 11 trained panelists, while the consumer acceptance was, that's consumer overall likability, was conducted by 99 respondents in Benin. So we see quite a good relationship between all of these attributes. And looking at the correlation between all of these attributes, we see a very good and significant correlation between the area between T naught and F max, which is the amount of work required to extend the dough until it's destroyed, which is also a measure of the extension of the dough, compared to stretchability, which is measured sensorially. The other parameters are also having a very high correlations, but were not shown to be significant enough. So based on this, we can confirm that stretchability and the amount of work required to extend the dough until structural failure is highly correlated, and a model can be developed on these attributes. So in the future, we intend to conduct more extensibility tests for pasty products, food profiles, such as fufu and eba. Already in the lab 2 days ago, we tried on eba, and the problem with eba was that it's difficult to roll eba into a thin sheet that can be extended. But for fufu, we have some confidence that fufu, which seems to be a more cohesive and less adhesive product, will be liable to this protocol. I want to acknowledge contributions by Benin team, who supplied us the 4 yam genotypes that were used to validate this protocol, as well as the Bill and Melinda Gates Foundation for sponsoring the RTB Foods project. Thank you very much. I will be pleased to answer questions from you, as well as Santiago is here also to answer questions, as well as Romain. Thank you very much.
Thank you, Toyin, for this very clear and detailed presentation of the procedure, which has been completed and validated very soon at CIRAD Montpellier with a contribution from FSA Benin. So, to be mentioned, provided that you can find more samples to apply this protocol on other pasty products by the end of the year, this procedure may be published in the upcoming special issue of the Journal of the Science of Food and Agriculture, which is being prepared at RTB Foods project level. So I'm sure YAM colleagues today on the call will have many questions for you, Toyin, or colleagues, but first I would like to give the opportunity to actually Santiago Arufe Villas, who's been very much involved in the development of this protocol, to introduce or reintroduce himself to all of you. And maybe Romain, if you feel ready to introduce yourself as well, please feel free to introduce yourself. So Santiago first, and maybe Romain.
Well, hello world. So I'm Santiago, a researcher in the CIRAD Montpellier since December 21. So I have working with Toyin and Romain and Christian Mestre to develop this SOP. So I hope you have a lot of questions that can help us to improve the SOP. And I would be glad to talk with you or with all of you in the next weeks. Maybe in Paris we will see each other. So hello everyone.
Thanks, Santiago. Romain, do you feel like introducing yourself? Okay, good, go ahead.
Hello everyone, so I'm Romain, I'm a technician in Calais Sud for the project, for RTB Food project. So I work with and the Toyin too, and Christian Mestre. And so I'm in Calais Sud for 1 year, and if you have some question about the procedure or something like this, you can ask to me too. And I will try to give you some response.
Thank you, Romain. Great. So questions, comments, feel free to raise your hand if you want to ask the question directly, or in the chat box if you prefer writing the question. So we have a first question from Noel. Noel Akisoe, who is asking, are you sure that the curve represents any indication of the stretchability, or let's say extensibility? Oh, Toyin, you're muted, sorry.
Yes, okay. Thank you very much, Professor Noel. From the indications so far in the work conducted, we think that this is representative enough of the extensibility of the dough. We are careful to call this attribute stretchability when it comes to the instrument measurement, because stretching involves more than just a uniaxial test alone. There might be other things that are important to consider when we are talking about stretching, measuring it by instrument, because there are some other protocols that are considered really very good for stretchability tests in doughs or like noodles, and we don't have that equipment so now in CIRAD. So I think Santiago can give us more insight into this.
Yes, so I think it's the same answer for me, and Toyin already said. We are very careful to call this SOP SOP of extensibility, because stretchability, as Toyin said before, is more than that. So we are not pretty sure to call it stretchability. But for the data we have until now, I think we can say that this SOP, or the data we collect with this SOP, can be related with the stretchability that is determined in the sensory analysis. So that's the most important thing up to now we can set, with being sure that we are saying things that are proven in the laboratory.
Okay, I hope it answers the question, Noel. I see that Bolanle, you have your hands up, please.
Yeah. Yes, good afternoon, everybody. And I want to appreciate Toyin for that nice and very clear presentation. Thank you very much. And the team, Santiago and Romain, I really, really appreciate the work that you have done so far.
Thank you very much.
And I also want to appreciate Toyin, the team, for clarifying between stretchability and extensibility, because I was wondering that why the term extensibility, but with the explanation that Toyin gave, that stretchability, they are being careful about the term stretchability. I really appreciate that, how you answered it. But then I have some few questions or maybe comments. When I was listening to the procedure, I saw that you used incubator and you said it's for it to relax. I didn't really understand the incubator, the importance or the implication, or why do we have to use incubator? The reason why I'm asking this question is that, okay, we are developing an SOP and we want it to be very, very similar to the condition in which the pounded yam is eaten. So I wouldn't understand, after we made the pounded yam, then I don't really understand the implication of putting it in the incubator. And then secondly, you said you were still trying it on EBA. I just want to call your attention to the fact that there are two types of EBA. We have the Yoruba EBA, we have the Igbo EBA. And so, in Nigeria, the two of them are different in terms of their stretchability and some textural parameters. So when you are testing the EBA, think about that factor, the two types of EBA. Thank you. And on a lighter mood, Toyin, you did not acknowledge the method for preparation of pounded yam. You didn't just develop it. You developed it, and you wrote it as if you developed it.
Yes.
So acknowledge Bowen University team, and it must be on record. Thank you very much. Thank you.
Yeah, you're right. Sorry about that.
Yes, ma. Thank you very much for bringing. We are sorry for not doing that. I think in the SOP that will be shared with all the partners, we acknowledge Bowen in the SOP, but we missed that in this presentation, so we are sorry for that. So regarding for EBA, we in just a brief test we conducted 2 days ago, it was very difficult to produce a sheet from EBA because EBA is very adhesive, and it's going to be very difficult to roll it into a consistent sheet. And
I agree with.
okay. And regarding the pounded yam being kept in the incubator for between 12 to 20 minutes, this is to relax the stress that was introduced by pounding the yam with the machine, because we found out during the experiments that below, if we were to produce a sheet from the dough immediately after pounding, the surface of the dough is going to be very rough and uneven, and we are not going to have a good representation of extensibility, because we don't have a fairly uniform surface. So the surface was quite rough, and we need time for relaxing the dough before we can roll it into the sheet. That's why it took us at least 10 to 20 minutes. But we're careful to make sure we don't let it stay too long in the incubator. That's why we had to look for the time, the best time possible. The range of time possible for us was between 10 to 30 minutes. So we capped it at just something between less than 20 minutes in the incubator, maximum 20 minutes. So that means that the last sample that was measured came out of the incubator at 20 minutes. That's the maximum time possible. So with this time, we believe that there would have been sufficient relaxation by which, when we roll the dough into a sheet, we can have a uniform flat surface and not rough surface.
Okay, thank you very much. So, and after bringing it out, after resting it for 15 to 20 minutes, was the surface smooth? And there's just one point I want us to note, and which is, anyway, it was in the incubator. It was not that the temperature was cooling, because we should take note of the tendency to retrograde. So yes. Was the surface, did it change? Was it smooth after bringing it out of the incubator? Since you said that was what you were trying to achieve. So what could, I'm just wondering that, what could be responsible for maybe the change in the surface or what, or making it smooth? But we should remember the factor of retrogradation on cooling. We should, because that could affect it. Just an observation, please.
Yes.
Yes. Yes. In fact, the use of incubator has two main things. One of them is that is in order to control the cooling of the dough also. Because when we do a batch of pounded yam, we have no time to measure usually with 450 grams, we take about 8 samples to measure. But if we don't put them in the incubator, they will cool very, very fast. And the first will be okay. But the 8th one, it will be so cool and so retrogradated that it will be completely different. So that's why also we are putting in the incubator. So when we are measuring the first one, the second one is still at 50 degrees, more or less. So then we can take it and roll it in a sheet and measure the sheet with the temperature of 30 degrees. Otherwise, it will not be possible. And we have to do a batch of not a lot of sample of each time to measure each sample in the same condition. So as Tojin said, it's very important the temperature. So that's why we use the incubator to maintain the temperature at 50 degrees, more or less. And then we also control the temperature during the textural measurement that control the cooling of the dough at about 30 degrees, more or less. So yeah, we do that also for this, for the retrogradation of the dough.
Okay, thank you.
In addition, I think the proper equipment and platform that should have been used for that, which I know is used for noodles, this Kifa dough rig, but we don't have that now in CIRAD. And even with that, there are also challenges with maintaining regular temperature for the samples.
Yeah, I think we all agree that it's the main challenge for this kind of SOP, to control the temperature and the retrogradation of the sample.
Yeah, absolutely. Right.
Okay, great. Thank you, Bolanle. Next question is from Cedric. During textural measurements, how do we come about to eliminate outliers? How do you eliminate outliers?
Okay, first of all, let me mention that in this protocol, we did not determine if they were outliers. But what is important to note is that we need to sometimes to build a measure of error into our products, into our measurements, because if we have a very clean data, it may not be real representation of the true situation in real life circumstances. So if we clean the data too much, there might be some problems. But we did not clean this data because we had very few readings for some. For instance, Yamdu was a bit difficult to handle. It was difficult to form into a sheet. The edges were rough, not as smooth as this. The one you see on the platform now is Laboko. So it forms a very smooth, nice, with well-rounded edges. So this shows that the polymer is not jagged. The structure is quite homogeneous enough, unlike for Yamdu, which was a bit difficult to roll into a sheet. So if we were to remove some data, we may have very few data to determine repeatability. For repeatability, at least we need like between 3 to 5 measurements per replicate, and we are conducting 2 replicates per genotype. So that means a total reading of about the minimum of at least 6 readings per genotype, or as much as 12 to 18 readings per genotype. So sometimes we try to form the dough sheet and it's not forming properly. We have to take another sample from the incubator and do it again. So that's why we did not consider removing. But if you are interested in removing outliers, there are many methods by which you can remove outliers. We can do an outlier analysis or use the IQR interquotient rule to eliminate outlier data within the data set.
Thank you, Toyin, for this detailed answer. Question from Dominique: have you found, or let's say, have you tried to establish any correlations with the results from the consumer testing of these 4 clones from Benin? So any correlation with the consumer testing, work package 1 activities?
I think from the PCA we have here, and the correlation coefficients and the probability, the only correlation that we found that was significant was between the sensory and the texture attributes, stretchability and area between T0 and Fmax. For the consumer overall likability, we have quite high correlations, but were not considered significant. You can see 0.87, almost, let's say 0.9, yes. So there was high correlation, but it was not statistically significant.
Okay.
So far from the data we have.
Yes, I just want to add something about it. Christian Mestre speaking. It is only on 3 cultivars. So if we add some other data, I am sure we will have a very good correlations between the texture measurement and the sensory data.
Okay, good. Thanks.
Yes,
thanks.
I want to add also that that's one point we would like to talk today, that now we are going to do more tests with different varieties to try to develop, to have a more data to analyze and to see all these correlations. So we are trying to do that in the next weeks.
Good. Question from Alexander regarding the terminology of stretchability versus extensibility. Alexander is asking, maybe we could consider stretchability as a mix of extensibility and stickiness. This is a question. Is it a mix between extensibility and stickiness? Stretchability, a mix like the two of extensibility plus stickiness resulting in stretchability. He's just asking whether extensibility plus stickiness make it stretchable or not?
We could not measure stickiness with this protocol because there were only 3 attributes we could measure: the area between the T0 and F max, extensibility, and hardness. So if we were to conduct a TPA, for example, on the pounded yam dough, we could obtain adhesiveness and or stickiness, and then we can see if there will be any good correlation between any of these attributes with stickiness. So with that question, I'm not very sure if there is any considerable relationship between the stickiness of the dough as well as its extensibility. Perhaps Santiago can shed more light.
Yeah, that is another key part of this SOP. Yes, with the data we have, we cannot set that. Maybe it's related, but as Tojin said, we have no test that can measure the stretchability or the extensibility and the stiffness at the same time. So for do that, in order to validate that, yes, we will have to do this test of extensibility, and in the same pounded yam, we have to perform the TPA and then do some nice stats and see if there are correlations between extensibility and stickiness, and that can be correlated to the stretchability. But summarizing with the data we have today, we cannot set that today.
Yes, and in addition, I think stickiness will not be considered a key priority trait when it comes to pounded yam, because nobody wants to eat pounded yam that is sticky. People like pounded yam that is moldy, cohesive. Yes.
Bolanle, do you want to add something to that?
Yes. Well, in my experience so far on the work of pounded yam, stickiness and stretchability will not be extensibility will not be a mix of stretchability and stickiness. Stickiness is adhering to the fingers, sticking to the fingers for the consumers. And also in the TPA measurement, stickiness is adhesiveness, adhering to the probe that is used. So it's different from extending or stretching. So I don't think the two of them can be a factor of extensibility. And as Toyin said, it is not a key priority to consider, but on the negative side, it's a key priority to consider because nobody wants pounded yam that is sticky, as he has said.
Mm.
So they don't want pounded yam that is very sticky. Like, you know, when they were presenting, they said the one from D. Alata, they couldn't mold it because it wasn't moldable. And I'm sure that while they were molding it, it was all sticking to the finger. And nobody wants to do that. So stickiness is different from stretchability. Thank you. That's just my contribution.
Great. Thank you, Bola. A question
from what
yes.
Professor said, it's important to note that one of the limitations of this protocol is that you may not be able to use it for genotypes that have such negative attributes, like that is very sticky, full of mucilages, and does not form a homogeneous sheet when rolled from the dough. So this may be a limitation of this protocol. Like I said, there are other protocols. There is the Kifa dough test protocol that can be used. And if you can purchase that Kifa dough setup, texture setup, you can conduct this using thin strips of pounded yam dough. So they will just look like noodles, and then you can extend and pull them and see how it pulls until structural failure.
Good. Question from Wasiu. Considering the heterogeneity of yam tuber composition, don't you think that different sections of the tuber, head, middle and tail, or the end of yam, may have different extensibility? To which Bolanle actually responded, the head and the tail may have different extensibility, but let's remember that we don't include tail and head when we are, or let's say tail probably, when we are pounding yam. So it may not be necessary to determine the extensibility of the head and the tail. Do you want to add something to this?
Yes, I agree with you. I agree with your response.
Okay, good. So let's go to Didier's one. How long does it take, this analysis? For example, if we plan to evaluate a large number of clones, a large population, how long would it take?
Okay, per batch of the test run, for each test run, like I said, we run each test in 2 replicates. So the first replicate took about close to an hour to evaluate, from peeling the tuber until conducting the test, the final stage of the test. So it took about an hour for each run. So that means that you can do replicates of 8 individual samples. You can do that within 1 hour. So if you want to conduct, let's say, 8 samples per replicate, and you want to do 2 replicates, which will make it a total of 16 samples, then this will take you about a minimum of 2 hours to conduct, because it takes 20 minutes, about 20 minutes for the yam to steam and pound, and it takes another close to 20 minutes for you to finish bringing out all the dough from the incubator, and then before you roll it into a sheet and conduct the test. There's also a limited period of time, about 1 minute it takes for it to cool down to 30 degrees before the extensibility is actually measured. So overall, it may take 2 hours for you to conduct 2 replicates of 8 samples per replicate, just for 1 genotype.
Thank you. Any more questions or comments to the team? I don't see any in the chat box. I see that regarding EBA, Elizabeth Parks actually has been mentioning that the EBA cannot form a thin sheet, and she's making a suggestion to use a dough from high quality cassava flour, which may be useful in this regards, to have like a proper thin sheet of EBA. So high quality cassava flour. Vasilyu, you have your hands up.
Yes, I thank you. Good afternoon, everybody. I think I have a question on the chat board. I mean, the chat box. The one I'm talking about, the size of the yam cubes.
Okay, this was a question then. Yeah. Okay. So it. Please ask your question orally if you feel like.
Thank you very much. I think I saw during the presentation, you mentioned pounding for 1.5 minutes. So I was skeptical that probably that may be because of the size of the cubes of the yam, that probably in the SOP, you may also want to include the size of the yam cubes that you've used. Probably other persons are using that same SOP, and the sizes of the yam are bigger than what you have shown us. They may also want to state that in there, for publications. That was my concern. Thank you.
Yes, I think we used a size following the protocol of Bowen on pounded yam, preparation of pounded yam, standard operating protocol for preparation of pounded. So we use about 2 centimeter cube dimensions for the yam cubes prior to steaming. So normally we ought to pound for 1 minute following the protocol of Bowen, but sometimes what we see is that for the other genotypes which were difficult to pound into fine homogeneous dough, it may take us a little bit longer. So we decided to use 1.5 minutes so that we can have uniform time for all the doughs.
There is a question from Didier. How long it take one genotype?
Yes, I've said it. It takes about 2 hours.
Yes.
So if you want to do 2 replicates for just a genotype, you divide into 2 replicates, and you want to take 8 samples per replicate. That makes it 18 readings per genotype. Then it might take up to 2 hours to finish that one genotype. For us, it took us 2 days to finish the test for all the yams.
Also, going back to the temperature topic, Hamos is asking, why do you have to wait for the temperature of the sheet to drop to 30 degrees before measurements? Just a question for clarification.
Yes, temperature is critical to texture characteristics. So we know that if you make a dough and it takes longer exposed to the ambient, it becomes relatively harder. And when texture attributes change, temperature is a critical parameter that we have to consider, because with temperature changes, you might have retrogradation occurring, realignment of polymeric units in the dough, as well as you may also have a number of other chemical and physical chemical changes that are occurring. So it's important that we measure at the same time, temperature rather, so that we can have reasonable readings. Otherwise, if you measure at 30 and you measure at 50, then you will have a dough with lower hardness, and it's going to be really, really, maybe perhaps even more extensible.
Yeah, and why we have chosen 30 degrees is because, in fact, doing this SOP is not able, we are not able to do to obtain a dough to be measurable at higher temperatures, because once we take the sample from the oven to roll in a sheet, they begins to cold. And for example, we cannot take 40 degrees because when we prepare our sample to the measurement, it was already 35, something like this. So we have done the choice to take it at 30 degrees, because otherwise it would be too stressful to do the protocol like this.
Yes, we don't want to rush.
Yes.
Bring out from the dough and you are rushing before you roll it into the sheet. Some time is gone and the temperature is dropping. So we decided to use 30 degrees because we found that the time it takes to roll the dough into the sheet before measurement, by the time we place it on the test rig, it's already like 35, 39. So we have to give it some time to cool down to the 30 degrees before measurement is conducted.
Well, thank you. I think it's time to close the webinar. So let's congratulate the whole team for the delivery of this new procedure. And let's acknowledge the key and crucial contribution from Bowen University team, who actually developed the procedure for sampling and lab scale preparation of pounded yam. So this procedure is actually already available on the RTB Foods website. So thanks Bowen, thanks Bolanle. Toyin, can you please remind us the next steps considered for similar applications on other PACE products, just so that we have it in mind?
Okay, it is our idea that perhaps we could extend this protocol to a product profile like fufu. This might be a question to the partner who is working on fufu in NRCRI. If stretchability is something important, a key priority trait, and I guess it's one of the traits that they look into in fufu. So if this is really important, then we might extend this to fufu. The good thing is that fufu is somewhat texturally closer to pounded yam than eba. So fufu is not very sticky, and it's not it's more cohesive and can be molded easily. So we think that they should form good dough sheets if we want to use this procedure for.
Good. To be continued then.
Perhaps,
okay, thank you. Thank you. I just want to add something about the presentation. I think we have to thank again FSA, because they provided the YAM, also they provided the sensory data and the consumer data that has been used to perform the correlation we can see on the screen. Thank you for them.